Alright, so let's answer some AWS things, okay, questions. So let's start. A media a media application uses Amazon CloudFront distribution to distribute static content configured on an Amazon S3. Alright, so there's an Amazon S3 or so there's an Amazon S3 web service that is hosting a website, static website. Okay, so a media application uses Amazon CloudFront distribution to distribute static content. So there's a CloudFront here to distribute this to the world. Alright, so you have if you have a user here, you have a user, it's this S3 website is getting distributed using CloudFront from maybe different regions like US, Mexico, Europe, and Asia. So it's using CloudFront. Okay, so the application is used to across different countries and various AWS regions. Some regions have been experiencing latency when there is a cache miss on CloudFront. Which of the following configuration changes will you suggest to decrease latency and improve user performance? So there are 4 options. So first option is redirect requests on cache misses to the S3 bucket nearest to the user country. Create a Lambda edge function to redirect requests based on the value of the CloudFront viewer country header. Associate the AWS the Lambda at edge. So we're not familiar really with Lambda at edge, so we'll still have to research this. So option number 2, redirect requests on cache misses to the S3 bucket nearest to the user country. Create a Lambda edge function to redirect request based on the value of the CloudFront viewer country header. Associate the Lambda edge function with the distribution's origin request. Yeah, we're still not familiar with that Lambda at edge. So let's try to see here. What is Lambda edge? Lambda edge. Please explain. Kaboom. Okay, let's see what is Lambda at edge. Lambda at edge is an extension of the AWS Lambda that allows you to run Lambda functions at AWS CloudFront edge locations. This means that you can deploy your functions in response to CloudFront events such as requests from viewers or responses from your origin, which helps reduce latency and improve user experience by running the code closer to the users. Here are some keys about Lambda at edge. Okay, so you can use CloudFront to distribute your Lambda functions. So it's called Lambda at edge. Deployment locations. Lambda at edge functions are deployed to AWS edge locations around the world, which are much closer to users than the centralized AWS Lambda service. This proximity allows for faster execution, um, for faster, where are we now? Faster execution of the functions and lower latency. Trigger events. Lambda at edge functions can be triggered by various CloudFront events. Request before CloudFront checks its cache or forwards the request to the origin request just before the CloudFront. Yeah, I'm already reading this for you, but yeah, you can search this one. Okay, so that is Lambda at edge. So our question is about static website, so it's not CloudFront at edge. So it should be the two remaining options, which is redirect request on cache misses to the S3 bucket nearest to the country. Create a CloudFront function to redirect request based on the value of the CloudFront viewer country header. Associate the CloudFront function with the distributions view request events. Yeah, I think that is the answer. Associate the CloudFront function with the distributions viewer request event. Okay, so let's see what is a CloudFront. What is a CloudFront function? Okay, what is a CloudFront function? CloudFront functions is a feature of the Amazon CloudFront that allows you to run lightweight JavaScript functions at the edge locations. These functions are designed for high-scale latency sensitive customization of your CDN content delivery network. They can manipulate requests and responses passing through CloudFront, perform authentication and authorization, generate HTTP responses at the edge, and more. Here are some key features and use cases for CloudFront functions. Lightweight and fast CloudFront functions can have sub-millisecond startup times and can scale to handle millions of requests per second. Security, the runtime. All right, so cost effective. So I think this is the answer. Distributions. What is CloudFront distribution viewer request versus distribution origin request. Okay, so let's try to see what's the difference. Viewer requests and origin requests are two different types of event triggers in Lambda CloudFront that you can associate with Lambda at edge functions or CloudFront functions to execute code in response to specific events. Viewer requests. This triggers occurs when CloudFront receives a request from a viewer, example, a client such as a browser, before checking its cache for forwarding the request to the origin server. This allows you to modify the request before it reaches the origin. For example, by altering headers, redirecting the request, or serving a different object. For origin requests, this trigger happens just before CloudFront forwards a request to the origin server. This gives you a chance to modify the request sent to your backend, such as changing the path or query parameter. It can also be used to generate responses directly from the edge locations without ever contacting the origin. Um, Lambda at edge functions can be triggered by both viewer requests and origin request events, offering flexibility to handle requests at edge stages of processing. On the other hand, CloudFront functions are specifically designed for lightweight transformations at the edge and only responds to viewer. Okay, so CloudFront functions only responds to viewer request triggers. In terms of use cases, viewer request triggers are often used for tasks that requires immediate response, such as redirection based on geolocation or device type, while origin request triggers can be used for more complex logic that needs to happen before the request reaches the origin, like A/B testing or access control. Right, so now we know that CloudFront function only responds to viewer request. All right. So another question here is, so let's delete this. You are a DynamoDB developer for an aerospace company that requires you to write 6 objects per second of 4.5 KB in size each. What write capacity unit is needed for your project? All right, so let's calculate. You want to write 6 objects per second of 4.5 KB each size. Okay, so 4.5, that will be rounded off to 5 KB in size each. So 6 times 5 is 30 write capacity unit. This is the write capacity unit that we need. So let's see the options. Option 1 is a 30. That is what we are looking for. Option 2 is 24. Option 3 is 46. Option 5 is 15. All right, so the answer is option 1, 30. Okay, so next question is, a video encoding application running on an EC2 instance takes about 20 seconds on average to process each raw footage file. Again, a video encoding application running on an EC2 instance takes about 20 seconds on average to process each raw footage file. The application picks the new job messages from an SQS queue. The development team needs to account for the use case when the video encoding process takes longer than usual, so that the same raw footage is not processed by multiple consumers. As a developer associate, which of the following solutions would you recommend to address this use case? I can't read. So the problem here is like this. So there's a queue. So messages comes to the queue. This is like a messages goes into the queue, and this queues will like expire by default for 14 days. It will expire. So if it's not gonna be processed for 14 days, it will disappear in the queue. So if you have a video encoding application, so this one here is your application. This is your video encoding application, and it's going to process each message here, and they are processing like 20 seconds per processing. So after 20 seconds, it will delete. So if it reads this, then after it processes this one, it should be able to delete this. And then if, for example, the message retention of this one, is it the message or visibility timeout? So if, for example, if this is 20 seconds and if the visibility timeout for this one is like 20 seconds also, the set was set to 20 seconds because they only need 20 seconds to process this. So if they set it to the visibility timeout to 20 seconds, but the processing takes more than 20 seconds, like maybe a minute or 60 seconds to process, this message will become available again here. And other applications, like for example music encoding, like another application, not a video encoding, music encoding. So it can see that, yeah, there's a message here that I can write, I can be able to read. So it's going to read that, not knowing that this application is still processing this message. So we need, this is a problem here. The development team needs to account for use case when the video encoding process takes longer than usual, so that the same raw footage is not processed by multiple consumers. So yeah, this is another consumer, this is a consumer. So if the visibility timeout of this one is 20 seconds, but it's already reached 60 seconds to process this, it will be available on the queue. And if this consumer here happens to stumble upon this message and tries to read it, then both of them will be reading this message, and it will cause discrepancy in your data, and yeah, it causes some issues. So the question here is, as a developer associate, which of the following solutions would you recommend to address this use case? Okay, so just use wait time seconds action to short pull and extend message visibility timeout. Nope. Use change visibility timeout action to extend the message visibility timeout. Yeah, this is what we want. Change the message visibility. Change the message visibility. Another option is to use wait time seconds action to long pull. Yeah, so this is not the case that we want. This wait time seconds is for short pulling and long pulling. So this is when the consumer tries to read it, and for example, if the queue is empty here, if it has no message to read, it will just wait here. Wait here for, maybe if he set the wait time seconds to like 30 seconds, it'll wait for 30 seconds instead of, if the wait time seconds is only set to 2 seconds, so every 2 seconds it will keep on working, like 2 seconds, try to find a message, it can find it, so another 2 seconds it tries to read again, and it still can't find it, another 2 seconds, still can't find it. So instead of doing that, the application will try to read, and then if it has no messages to read, it will wait for 30 seconds, and if it already detects a message and maybe 20 seconds time, it will immediately read that and then process that, and so that's the case. So the answer for our question is just use the change message visibility action to extend message visibility time. All right, so that's it for now. I'll just continue again for the next video. All right, too cool. All right, let's try to draw some girls here. All right.